Yo, what's up, class? How you guys doing? We've done lots of topics, and now we're at another interesting topic called the oxidation and reduction. Somebody say oxidation and reduction. Oxidation and reduction. Now we're going to talk about oxidation and reduction in terms of addition of a removal of oxygen and hydrogen. We're going to talk about oxidation and reduction in terms of electron transfer. We're going to talk about the use of oxidation numbers. There we are going to do lots of calculations, you understand? And we're going to talk about test of oxidizing agents. Okay, and I'm going to also teach you something, which is how to balance redox reactions. How to balance redox reaction. Are you ready? Are you ready? Come on. Are you hearing me? I say, are you ready? Let's go. Let's go. Let's go. Let's go. Now, differences between oxidation and reduction. Number one difference, addition of oxygen, removal of oxygen. Now, when you talk about oxidation, now oxidation can be defined in 4 ways, but based on your JAMB syllabus, we're given 3 ways of defining it. 1, addition and removal of oxygen and hydrogen, and in terms of electron transfer. Now, oxidation can be defined as addition of oxygen, are you getting me? Removal of hydrogen, electron loss, removal of electron, and addition of electronegative elements. But we are not dealing with addition of electronegative elements. Hope you understand. So, first of all, let's talk about oxidation based on addition of oxygen. If I give, for example, carbon, I'm talking about addition of oxygen. Let me write it out. Addition of oxygen. If I give carbon reacting with, carbon is X, reacting with zinc oxide. Now I'm going to have something. I'm going to have carbon 4 oxide gas plus what? Zinc. Now let's balance this. If I put 2 here, yes, and I put 2 here, it's balanced. Now, oxidation can be defined as in the terms of when oxygen is added to an element, to an atom, you know. Now look at this now. Carbon reacting with zinc oxide, zinc 2 oxide, sorry, to give me carbon 4 oxide and zinc. Now they ask you, what is oxidizing? What is reducing? Are you getting me? What is the oxidizing agent? And what is the reducing agent? Now listen, oxidizing agents undergo reduction. So now, if reducing agent undergoes what? Oxidation as well. Are you getting me? Now look at this. If oxidation is the addition of oxygen, then that substance in which oxygen is added to is the reducing agent. Do you get that? If oxidation is the addition of oxygen, then that substance in which oxygen was added to is what? The reducing agent. Now let's look at this. Carbon, here is single, right? Carbon here. This zinc 2 oxide has given oxygen to this one. Are you getting me? So carbon has now turned from carbon, which was just carbon, to carbon 4 oxide. Oxygen has been added to it. So what has taken place? Oxidation. Carbon was single here, here oxygen was added. Then this carbon, are you getting me? That oxygen was added to is what? Reducing agent. Are you getting me? Now, reduction can be defined as removal of oxygen. Now, zinc 2 oxide had oxygen, and the oxygen was removed from it. So zinc 2 oxide has now been reduced to zinc because oxygen has been removed. So zinc 2 oxide down like this to zinc. Here there was oxygen. I took away oxygen. Now it's just remaining zinc. So removal of oxygen is what? Reduction. So reduction has taken place there. And then the substance in which oxygen was removed from, right, is the what? Oxidizing agent. So oxidizing agent undergo reduction, reducing agent undergoes what? Oxidation. Do you get that? If you get that, say yeah, yeah. Yeah. You know my name. What's my name? Mr. What? Dave. Let us flow. Now, another one is removal of hydrogen. Oxidation can be defined in terms of removal of what? Hydrogen. While reduction can be defined in terms of addition of what? Hydrogen. Now, how do I mean? Let's do another example. Removal of what? Hydrogen. Now, example, if I have hydrogen sulfide gas reacting with chlorine gas to give me what? HCl. I get to me gas plus what? Sulfur. Now removal of hydrogen. Now let's do this. Now the removal of hydrogen, that term is what? Oxidation. Addition of hydrogen is what? Reduction. The substance in which hydrogen was removed from, okay, which undergoes oxidation, is now the reducing agent, and the substance in which hydrogen was added to, which has undergone what? Reduction, is now the what? Oxidizing agent. I don't know if you understand what I'm talking about. So let's look at this hydrogen here. Here we have hydrogen sulfide. Here we have sulfur. So hydrogen was removed from here to give me sulfur. Hydrogen was removed. So that means what is happening? Oxidation is taking place. Are you getting me? Good. Now this substance in which hydrogen was removed becomes the what? Reducing agent. So reducing agent has undergone oxidation. Now don't always feel that they will start with reducing agent always. No. I can decide to start my chlorine first plus this. Are you getting me? So it's not every time Ra is always is always beginning in the sentence or in an equation. No. Now look at this. Here we have chlorine in its free state. Now reduction is addition of hydrogen. Now this hydrogen has been added to chlorine to give me HCl. So I'm going to have this. Are you getting me? So hydrogen was added to chlorine to give me what? HCl. So what has taken place here? Reduction. So the substance in which hydrogen was added to, are you getting me, has undergone what? Oxidation. So the substance which hydrogen was added to is what? The oxidizing agent. Sorry. Very simple. Hydrogen was removed to give me sulfur in the free state. Hydrogen was added to chlorine to give me hydrogen what? Chloride what? Gas. Hope you're not confused. Good. Now, let's talk about oxidation and reduction based on electron loss and based on electron gain. Now, when you talk about oxidation is a substance in which donates electron. That means they lose what? Electron. So let's put it now. Electron loss or gain. Or what? Or gain. In which electron is being lost. Now when electron is being lost, that phenomenon is what? Oxidation. So oxidation is taking place when there is loss of electron. Now that substance which loses electron or which donates electron becomes the what? Reducing agent. Now reduction means it talks about gain of electron. So the substance that gains electron or accepts electron. Are you getting me? So that substance that accepts the electron becomes the what? Oxidizing agent. So oxidation is the process whereby a substance, okay, loses what? Electron. While reduction is a process whereby a substance what? Accepts electron. Then the substance that loses electron is the reducing agent, and the substance that accepts this electron is what? Oxidizing agent. How do I mean? Or how do I know a substance is undergoing oxidation? Now, increase in the oxidation number from the reactant to the product is what? Oxidation. Product shows oxidation. And decrease in the oxidation number from the reactant to the product shows reduction. Sorry, shows reduction. Now, look at this. If there is an increase from of the oxidation number of a substance or an element or an atom, okay, or an ion, from the reactant to the product, if the oxidation number increases from the reactant, I told you reactants react, two substances reacting, coming together, they combine, to give birth, okay, to the product. Okay, so that if there's an increase from the reactant, okay, to the product, okay, it shows that oxidation is taking place if the oxidation number increases from the reactant to the product. Now, if there is a decrease in the oxidation number from the reactant to the product, shows reduction is taking place. So how do I know the increase in the oxidation number and the decrease in the oxidation number? I will know this through knowing how to calculate what? Oxidation. So how do I do this? Now, I'm going to still come back to explanation of electron loss and electron gain. Let us push further so that, when you're building a house, it's only the house they build in the sky that when you want to build a house, you start with roof. You roofing. You buy zinc. I don't know whether that's what they do for your village, but I know that if you want to build a house, you start from the what? Foundation and build. You can't want to start building a house now. The first thing you're buying is zinc. It's a problem. They need to take you to see a doctor. Or you're building a house, you now put zinc first. No. Or you put window first. How the window won't take stay? So everything is a building process. So before I come back to explaining more on electron loss and electron gain, let's do oxidation number so you understand how it functions. Now, oxidation number. What's oxidation number? When we talk about oxidation number talks about the electric charges an element or an atom or a compound possesses, which follows a set of arbitrary rules. I get me? Is the electric charges an element, atom, or ion possesses, I get me, which follows what? A set of arbitrary rules. And we have rules that governs calculating oxidation number. Number one, the first rule. Oxidation number, ON stands for oxidation number, of an atom or element in its free state. When we talk about free state, talking about uncombined state. Is what? 0. Oxidation number of an element in its free state or uncombined state is what? 0. Example, if they say what is the oxidation number of sodium? If I just have sodium, is what? 0. What's the oxidation number of chlorine molecule? Is 0. Are you getting me? What's the oxidation number of let me say of potassium? Is 0. What's the oxidation number of iron? Is 0. What's the oxidation number of oxygen? Is 0. Now, it is not combining. They are existing on their own. So such kind of element or such kind of atom which are in its free state, or a molecule self, which are in its free state without combining with another element or a different element, are you getting me? It has an oxidation number of what? 0. I don't know if you understand. Now, the oxidation, the charge of an element, whether it's negative or positive, I get me, the charge of an element, I'm giving you the rule, another rule, the charge of an element, whether it's, or atom, I get me, whether it's negative or positive, has the same size, I get me, and has the same, it has the same size as the oxidation number. The charge of an element, whether negative or positive, has the same size as the oxidation number. I get me. For example, if I have Fe2 plus, the charge is 2 plus. So since the charge is 2 plus, the oxidation number is what? Plus 2. Now, oxidation numbers, you write the signs before the numbers. I get me. If I have chlorine minus, the charge here is -1. So the oxidation number is what? -1. Are you with me? If I have sodium plus, the charge here is what? +1. So the oxidation number is what? +1. So the charge of an atom, the charge it possesses, or an ion, or the charge of a molecule, sorry, the charge of an atom or an ion has the same oxidation number. It has the same size with the oxidation number. I get to me. I just gave you an example. We also have, if the oxidation number of a compound, the charge of a compound. Now, compounds have charges. I get to me. When we define an ion, we said an ion can be an atom that possesses a charge, or a group of atoms. So a group of atoms coming together to have a charge. Okay. Now, the charge of a compound, that is group of elements that combines together, the charge of that compound, okay, has the same oxidation number as the compound. Example, what am I talking about? If I have Cr2O6 2 minus, 2 minus is the charge of this compound. I get me. So the oxidation number is what? -2. I can have MnO4 minus. The oxidation number of these is what? -1. I get me. I can have NH4 plus. The oxidation number is what? +1. So the charge of the elements combined together to form a compound, the charge of this has the same oxidation number, Are you getting me? Are you getting me? Are you with? So the charge also can be gotten by the sum of each of the oxidation numbers of the elements. The charge can be gotten, of the compound can be gotten by the sum of each charges of the elements. Are you getting me? The sum of this charge by the sum of this charge will give you the charge of everything. Are you getting me? So that is another rule that you need to know. Another rule is that the oxidation number of a compound has the same charges as we just explained now. Has the same charges also. For example, if I have H2SO4, the oxidation number of this compound is 0. I get it. Now, if there is no charge given in a compound, if you have a compound and there is no charge given on it, there is no positive or negative charge given, the oxidation number of that compound is 0. Are you with me? I can have potassium tetraoxomanganate 7. There is no charge given, right? The oxidation number is what? 0. I don't know if you understand. So that's one law. Now, the oxidation number of oxygen usually is -2. If I have oxygen, the oxidation number of oxygen is -2. I get it. So that's why oxygen has a charge of 2-, right? But when oxygen is a peroxide, this is an exclusion for peroxides. Now, peroxides, for example, hydrogen peroxide, H2O2, the oxidation number of oxygen here for peroxide is -1. Are you with me? So every compound that has oxygen, the oxidation number of oxygen in that compound is what? -2. But for peroxide, the oxidation number for peroxide is what? -1. We also have again hydrogen. We know the oxidation number of hydrogen is what? +1. But for hydrides, when you say hydrides, hydrides are when hydrogen combines with a metal. Now that metal is now the positive ion. The hydrogen is now acting as what? Negative ion. Example, if I have sodium hydride, I can also have potassium hydride, for example. Now sodium is the metal already, so this is N. Sodium is the metal already. Potassium is the metal already. Are you getting me? So this hydrogen is not acting as a positive ion now. It's acting as a negative ion because it's combining with a metal which is positively charged. So the oxidation number of hydrides when hydrogen combines with a metal is what? -1. But the oxidation number of hydrogen is +1, except if the hydrogen is a hydride. That is when it is reacting with what? A metal. You get that? Good. So now let's calculate. Now they say, what is the oxidation number of manganese in potassium tetraoxomanganate 7? What's the oxidation number of manganese in potassium tetraoxo what? Manganate what? 7. Very, very simple. Now, they've already given the formula for potassium tetraoxomanganate 7, which is KMnO4. So what do? You have K plus Mn plus how many? 4. How many oxygen? 4 oxygen is equal to, now remember this law. Are you getting me? The law we stated that the oxidation number of a compound when it doesn't have a specific charge is what? 0. So if you check here, the oxidation number of this compound, it doesn't have a specific charge, right? It doesn't have a specific charge. So the oxidation number is what? 0. It's equal to 0. Are you following? Good. So now, what is the charge for potassium? Potassium, we know that potassium is number 19 in the periodic table. 2:8:8:8 what? It's what? 1. Thank you very much. Now, it's losing 1. 1 electron is going. But because 1 electron is going, it has a charge of what? +1. And since it has a charge of +1, the oxidation number is what? +1. Remember, the law we said, the charge of a metal of an atom has the same oxidation number of that atom. So since the charge of potassium is +1 because it's losing +1, that means the oxidation number of what? Potassium is what? +1. Now calculate the oxidation number of this. Now we don't know because that is a transition element. Mn plus 4. Now what's the oxidation number of oxygen? Oxygen have it 2:6. It's accepting how many? 2. That means oxygen has a charge of -2. And the charge of that oxygen, which is -2, is the oxidation number of what? The oxygen should have -2. Equals to 0. So I have 1 plus Mn minus 4 times, which is 8, is equal to what? 0. So I have Mn is equal to, sorry, let me do so you understand. So I have 1 minus 8 plus Mn is equal to 0. It's going to give me -7 plus Mn is equal to 0. So I have Mn is equal to what? Plus what? 7. That's my answer. Very, very simple. Now if you don't understand, you can play the video over and over and over and over to understand. Are you getting me? Good. Now let's push forward. Now they say the oxidation state of sulfur in tetraoxo sulfate 6 is dash. So I have tetraoxo sulfate 6 is dash. Let me put acid. Tetraoxo sulfate 6 acid is dash. What's the oxidation state of sulfur? Now tetraoxo sulfate 6 acid, we know is H2SO4. Are you getting me? Now this does not have a charge, so automatically it's equal to 0. So this is what's the oxidation state for sulfur here. We have 2H plus 2H, sorry, plus S plus 4O is equal to 0. Are you getting me? So what's the oxidation state for hydrogen? We put 2 because H is 2. Are you getting me? So what's the oxidation state for hydrogen is plus 1. So I have 2 plus 1 plus S plus 4. Oxygen is what? Minus 2 is equal to 0. So I have plus 2 plus S. There's no need putting this plus to get our final answer. Okay? Minus 4 times this will give you minus 8 is equal to 0. And getting me. So I have X is equal to what? If you do it, we have what? Plus what? 6. Very, very, very simple. Are you getting me? Let's say calculate the oxidation number of Cr2O62 minus. Well, we'll come back in our next lesson. We will continue more. Thank you and stay tuned.